Because you see, I would have, if I had unlimited funding, I would have developed a tech base to such an extent it looked like it come out of Space 25, right?
The mind would be working in a totally different way.
Yeah. Okay, so the key was, how can we duplicate this thing in the muon process, but do it in a way that was very safely? So what the Lord had shown me was, number one, that in the process, that I need to stabilize and prevent the water molecule from occurring. Okay, so I have now to set up this condition to prevent the water molecule from combining together to go into stabilization. What I have done now is, when I had re-exposed the combustible gas atoms to what we call the hydrogen gas gun technology, in other words, the gas is going back through another high voltage field, and as it's going through this voltage field, then electrons are now being plucked off of that atom, and as a result, I'm now taking the combustible gas atoms into critical state. Now the question number one is, how much energy does it really take to trigger a thermonuclear device? Anybody know? Very low. Because all they do is they set up the subcritical mass here, and the subcritical mass and put them here, and goes into critical state. It is a physical, they've taken it from a physical to that and injected with laser energy to trigger the process to come up with the MERV warheads. So it takes very little energy to do this. If you set up a destabilization state. So what I'm doing now is take the combustible gas atoms like the hydrogen atom, re-expose it to a high voltage field to ionize that oxygen atom. Now, to aid the process a little further...
You're ionizing the oxygen atom.
Right. Well, I can do it with the hydrogen too. I'm elongating it because I'm changing it. So what I'm doing with the hydrogen oxygen atom, in this case, I'm now subjecting that atom to laser energy. Now, when I subject this to laser energy, it now goes in even to a greater destabilization state. So I've now taken it in a subcritical state, have I not? So as I also expose the hydrogen atoms to laser energy, they become weakened.
More unstable.
More unstable. And an example of this is that when the nucleus of an atom absorbs laser energy, I know all physics something's going to happen, right? So what takes place is that the hydrogen electron now starts to move farther away from the nucleus, and as it does this, the electrical attraction force becomes weaker. So she and I, no. Yeah, she and I are out on a basketball court. And she's the hydrogen atom, right? Now I've just zapped her with laser energy. Zap. And since I zapped her with that, she has now become into the weakened state. Now I'm the big oxygen atom.
How much are you?
And I'm 8 times bigger than you are, right? Now, in the meantime, I've gotten 4 electrons or more plucked out of the oxygen atom. And an oxygen atom, if you will now take away at least half of its electrons, it acts like a baby and says, if I can't have any more of my electrons, I'm going to blow apart. Well, I got 4 missing electrons, and the law of physics says I have to stabilize, right? Okay, now, so in the meantime, I'm 8 times bigger than she is, and I've got 4 times greater electrical power reason to grab a hold of her electron. So we're out on a basketball court, and then some who goes over and likes the gas, and she rushes to me to link up to me. And as she's coming to me to try to link up to me to form the water molecule, I'm looking at her electron, right? Now, when I grab a hold of the basketball, which is her electron, who's going to win out, me or her?
You.
I'm going to win out. And if I win out, is she any more a hydrogen atom?
No.
No, you're a measly little proton. And all that energy that's in your nucleus, you got to release. And so it starts to release that energy that's been stored in that hydrogen atom because I plucked out the electrons. Since this has now been exposed to high laser energy, and it's in a destabilized state, it can't form the water molecule. And as a result of this, the implosion effect occurs and starts releasing tremendous amount of energy safely, and its energy yield at a minimum is 2 1/2 times that of gasoline.
So that's a nuclear reaction.
Well, it's called...
It becomes a nuclear reaction at that stage.
Yeah, well, when remember the analysis says they either go to another atom state or an implosion effect will occur. Since the hydrogen atom is the least of the atom structure, it can't stabilize into another atom. And therefore the implosion effect occurs and starts releasing all this energy, which now taps into that little apex or opening areas to allow the other energy to come in.
And is this coming out of what? Heat explosion?
Thermal explosive energy. Tremendous amount of energy.
This is what you want happening inside your internal combustion engine. For
Oh, no.
Right.
This is the second stage.
This phenomenon I discovered this by accident, where I triggered a volume of gas in a metal container, all right, that had a leak. But the leak was just sufficient to control the amount of air going into it, and that thing heated up to super red hot before it exploded.
Yeah.
Stan, could
Well,
I
this-
just ask a question there for a minute?
Yes.
If you could digress. Could you quickly explain to us what happens in different terms between, because it's the same effect, I believe, in a nuclear explosion and what you're doing there now. We're dealing with the same kind of concept.
No, it's entirely different. On thermonuclear, you're dealing with like the billiard ball effect, that you're trying to bombard the nucleus, the nucleus, to knock out its components.
But you still
Okay.
have
It's an
that energy
explosion.
source, the key,
Well-
the fourth dimensional source, as you call it.
Well-
It still comes into it, doesn't it?
Well, no. This is a triggering process. All right, we're using voltage to set up the destabilization, and we are triggering it. Now, for an example, scientists were ignoring when they were looking at hydrogen fusion that 1/3, or the sun, is composed 1/3 of oxygen atoms. Now, in a particular process, these atoms have certain native intelligence to them. Just like humans have intelligence, animals have intelligence, so does atoms. And the oxygen atom has a very unique intelligence over any other atoms. What is it? It has the unique intelligence to trigger and release thermal explosive energy from other atoms. What proves that out? Well, in the gas combustion process,
Yeah, of course.
would need the oxygen atom to accomplish that. That's the only oxygen atom that has that capability.
Catalyst.
All right, now let's look at it another way, and then I'll go back.
I think you called it an implosion, where a nuclear reaction is an explosion.
And
Yeah,
also
you're
release
fragmentizing. You're actually trying to fragmentize. In this one, you're not trying to fragmentize.
What else do
You're
we
looking
want?
for the triggering mechanism to
I was looking
increase
at
mass
the
density.
energy involved rather than the mechanisms concerned. I wonder whether there's a parallel there, just in terms of the energy involved.
Well, I never really. I'll think about that and give you an answer. Let me go calculate
Stan,
that.
what's left after you get this energy out? What's left?
Nothing. There is no fragmentation of particles. It's pure energy.
So the oxygen and the hydrogen both disintegrate into pure
Right,
energy.
and then totally consumed.
I see.
Totally consumed into pure energy. Okay, now another example of this is when you're burning logs.
Now you said 2.5 times the gasoline. You don't mean just
I'm
burning
sorry.
the gasoline.
I'm sorry. No. 2.5. It's 2.5 or 2.5 billion. Million.
Million barrels.
2.5 million barrels of oil per gallon of water.
Ah, right.
That's the amount of energy going. Yeah, not 2.5 times gasoline. The 2.5 million barrels of oil per gallon of water. So when you go home, take a barrel of oil about 10 high, and go down the freeway all over where you come, and then hold up 1 gallon of water. That's 2.5 million barrels of oil. Now this is a triggering mechanism, and once it triggers, it can't stabilize, so it has to continue to go on. And the analysis also is like burning logs. You know, in wintertime, have you ever burned logs? All right, now when you burn the log during the gas combustion process, are you not changing the atomic structure of the log? Yes, you're changing the atomic structure of the log, and as you're doing this, you're releasing that thermal heat energy from the log safely. Now you're releasing that energy up until the time that ash is formed, is it not? You know, as a little kid, my dad said, after we had the nice fireplace the night before, he said, son, it's time to clean up the fireplace. Well, you know, I was about 9 or 10. Well, Dad, what is this black stuff? Well, it's soot. Well, what's soot made out of? Well, it's made out of carbon atoms, right? So the gas combustion process was terminated or stopped when the carbon atom was formed. Now, if you would prevent the carbon atom from forming, would not the process continue to go on until another atomic structure is formed? The same analysis is here with the hydrogen fracturing technology, except the hydrogen atom is the least of its technology, least of the atoms, so it cannot stabilize into another atomic structure. It goes on into an implosion effect and releases this tremendous amount of thermal explosive energy and releases it safely. This is why we can literally fly a tactical aircraft like an F-18 an F-16 and fly off the atomic power of water. And matter of fact, we are now retrofitting the technology to an equivalent to a Learjet, like a T-39, which will show and demonstrate, in fact, they're doing the exact same thing of flying around the world.